In this tutorial, we are going to learn how to acquire a contact mode AFM image by using Bruker Dimension icon. As you can see, this is the AFM head. If I just unscrew, here is the cantilever holder, which is now attached to the head. So if I just put it here, this head consists of piezoelectric scanners, X, Y, and Z. So when we attach this holder with the cantilever to the piezoelectric scanner and the laser which falls on top of the cantilever and then reflected back to the photodetector. So what we have to do is mount a cantilever, attach to the head, and then align the laser so that the laser is just on top of the cantilever, and then which reflects back to the center of the detector, so which we adjust by using these two knobs. Okay, so I will put it here for a moment. So let's take this cantilever holder and then attach a cantilever. Okay, I will place the holder on this stage to exchange the cantilever. So before mounting, so let's choose which cantilever we have to mount. So as we are going to take a contact mode image, so the cantilever which I take is it's from budget sensor Cont ALG, which has a spring constant of 0.2 Newton per meter. Okay, so I take the cantilever, put it in the place, and then clamp it back. Okay, that's it. So just place the cantilever as it is, not upside down. So now let's mount this back to the AFM head. Okay, I tied the screws. So now what we have to do is align the laser by these two knobs, X and Y direction, and after that align the detector by using these two knobs. Okay, let's do that. So before that, open the software. Okay, so let's open the software, Nanoscope 9.4. When you open, it will pop up with a different option. So which mode you want to use. So it's already selected here, contact mode. So let's select contact mode in air. Here also select experiment, contact mode in air, and then say load experiment. So it takes a while to load. Once it's open, so you already see here a cantilever with a blurry picture. So let's start from setup. So just click on the setup. You already see the cantilever, so I just select here, mark it so that reference of my tip is somewhere here. In this setup, we align the laser and also the align the laser to the center of the detector. Okay, first let's select the probe. So as I showed previously, the probe name is Cont ALG. Let's see which is, it should be already in the library. So Cont, yeah, it's here, Cont ALG. It has the values of spring constant and the deflection sensitivity. And now I just say return and save changes. So next step is to align the laser. So either we can use the align laser on the probe, clicking move to alignment station, or usually the laser is very close to the cantilever, so you can just use the knobs, these two knobs, and look at the cantilever and see whether you can see the laser spot. Yeah, so I'm just there, and then you can just go out. So I will just decrease the illumination here, the light. So you just go out and then look at the sum value here. When you bring in the laser on top of the cantilever, so you should get a maximum value. So for this cantilever, the intensity is I mean the sum value is something 4, which is reasonably good already. So don't go too much backside of the cantilever. So it's somewhere here where we get 4.4. I will stop it here. Next step is to center the laser to the photodetector. So you can see here the vertical value is 10.8 and the horizontal is minus 12. So I do this by using these two knobs. Turn. Now the horizontal is changing, so I bring it close to the 0. Okay, and then the other one, vertical, now close to 0. Okay, so I can fine tune again the other one. Okay, so that's not bad. So now yeah, we are almost done. The focus to the tip, so which is already focus almost. Yeah, that's quite good. So we are done here with the laser alignment and the aligning the laser to the photodetector, center of the photodetector. So next step is the navigation, where we actually place the sample and focus to the sample. Okay, so let's today try to image this sample, something fun AFM grading. So this actually has some funny graphics composed from small pixel etched on silicon surface. So let's see how they look like. Okay, so place this sample here. So now move the stage so that the sample goes underneath the scanner head. So by using this navigate panel. Okay, so then by using these two icons, I can move the head up or down. So I bring it down. So as close as possible, I mean by your eyes. So I think this is the maximum. I can go a little bit down. Okay, and then I will bring it back to the sample. Okay, you can already see some kind of structures on the sample here. So let's try just go somewhere here, clean area. Okay, and then focus very well to the sample. Okay, so almost focused. Here navigate panel, what we do here is loading the sample, just focusing the right area of your sample. And the next step is to check parameter. In the check parameter, you actually give a sample size, like scan size, how big area you want to scan. So let's say I want to scan 5 micron area. Aspect ratio, leave it 1. Offset, I don't want 0, 0. Scan angle, depends which direction you want to scan. So let's say 0. Scan rate, let's say 1 Hertz is fine. And samples per line, so 256 line, like 256 points and 256 line. It's like a pixel for your image. And the gains and the deflection set point, we will tune it later. Okay, so after this we can say engage. So before engaging, we have to be sure that the cantilever is well focused. So let's double check again. Yes, it's focused well. And vertical horizontal is almost 0 and the sum is fine. So in the navigate, we focus to the sample, which is a little bit maybe fine tune again. Okay, Focus to sample, check parameter. Yeah, we selected the scan size and the rate, everything. So let's say engage. So now a motor is moving from the tip focus position to the sample focus position. So when it reaches the 0.5 volts, the deflection of the cantilever, it starts imaging. So now you can see something is imaging already. So now what we have to do is controlling the feedback for the better tracking. So first is to look at the scale here. So the scale is 10 nanometer and our feature size is much higher. So what we can do is simply do auto scale. Okay, so now we can see something. So now let's try to tune a bit gains and the set point. So I will increase the deflection set point to 1 volts and play a bit with gain. So I increase a bit gain. So the best way is increase the gain till you see some noise. So here you see there are two images. One is the height image, left side, height sensor image. The right image, the deflection error image, is the difference between the set point and the measured voltage on the photodetector. So what you can do is simply tune this one, integral gain, till you see some noise on the error image, and then you can decrease it just below that. Okay, so the other way is bracketing. So you just go step by step, like integral gain and also the deflection set point, and see which is best number for your by looking at the quality of the image, which is the best number. So integral gain takes most of the feedback, like 80% of the feedback, and the proportional gain doesn't affect much. Okay, so it's not bad. So we have changed something in between. So I will start from the beginning again. Okay, so let's make a folder to save this. Capture file name. Okay, so it says capture is done. So then let's take another image by increasing the scan size, 40 micron image. So let's say start from the beginning. Okay, that's saved. So we can see a couple of smiley graphics on the image. So let's try to zoom this one of the smiley. Okay, say execute, and then try to rotate this smiley. So start from the beginning. Okay, it's done with the capture. So let's say withdraw. When you say withdraw, the head moves up and goes back to the position to the focus of the sample. Okay, so that's all about acquiring a contact mode AFM image. So now let's move to the image analysis, extracting the profiles or measuring the distance between 2 points, and also measure the surface roughness from the saved image. So once you acquire an image, open the Gwydion software and open the file which we saved. So let's take, for example, this image. So when you open it, usually come with black and white. So you can change the color by right clicking on the color bar here. Okay, so first step is to level the image. So as you can see, there is some tilt on the sides here. So let's just say data process level, plane level. So I did a little bit, but I think there is still some more. So you can again do level to remove the polynomial background. Let's say 2. Just take it out. Okay, now the image looks quite nice. So you can fix the scale bar to 0. Use this appropriate icon here, or you can just right click, fix 0. Now it's from 0 to the maximum height. So now if you want to measure the distance between these two structures, so you can just use a measure distance icon here, and then you can just drag a line. So you should be able to read the values here. Or you can also extract the profile directly. So say extract profile and then drag a line. For example, let's take a line here. So this is the profile, particularly on this line. So you can say apply, and then you will be able to read the values here. Okay, so or you can also move this. Okay, so regarding the roughness value, so you can just click on this calculate roughness parameter and then drag a line across. So you should be able to get a roughness values. For example, here already shows average and RMS, as well as some other roughness values along with the profile. So you can move this line across the image to get the profile and the roughness values across the image. So this is just for one line. So if you are interested in roughness of the entire image, so you can just click on the statistical quantities. So you will be able to see the roughness values here for the entire image. So here also you can select an area of interest if you are interested in only calculating the roughness in this box. You can say update. Yeah, so that's it. So this is how you measure roughness from an acquired AFM image. I hope this tutorial will help you to understand at least a little bit of AFM and acquiring an image using the contact mode, and how you can get the roughness values from the acquired image.